Booster 19 is actually the second of the version 3 boosters that we've built. Booster 18 came before it. We had an unfortunate anomaly during our first test campaign of the Booster 18 vehicle. This is the first version 3 booster that we built, so this is Booster 18. This is really awesome because it's going to be our first full vehicle level operation and test with a version 3 vehicle, so the whole team's very excited about this. Sure hope it works. When we were pressing the nitrogen system, we had an explosion that took out the rocket, and thankfully we had designed that test to be safe. If something like that happened, we did not have propellants or reactive things on the vehicle, and so the test site incurred very little damage, and of course nobody was hurt in the incident.
Yeah, as part of testing, this is loud, so you learn to not be super skittish as you're walking around. So we have our booster here on site. We're going to be performing a cryo-proof. It's actually a really long day, so it's nominally planned to be a 12-hour overall prop load and offload. It's just a ton of propellant that we're putting on the vehicle, and we do a bunch of test cases throughout the whole day. So it's a long one.
Taking booster SM to cryo high fill proof.
Cryo-proof is the first time you actually put propellant onto the vehicle. The liquid propellant that we're putting on, it does get pretty cold, generally in the 80 Kelvin range. We want to test like you fly and fly like you test.
No on 70% proof percentage. Confirm. And fuel interface is fully cryo now.
There is definitely nothing like a late night with your team in the control room. It's one of those milestones where you're like, wow, if I can load a rocket, this is amazing.
The FHT looks pretty stable. Let's go ahead and get booster configured for offload. Copy.
This is a Raptor 3. V3 is a high-performance boost engine. It's also designed to be reusable and highly reliable. We've learned a lot over the course of producing around 600 V2 engines. You can see the amount of simplification that's occurred between V2 and V3.
Look at that, guys. If you guys go back to that, right? If you go back to that,
you can see the amount of simplification that's...
Look at the difference between the left one and the right one. This is how quick they move in all of Elon's companies in order for them to get to where they need to go. He always said the best part is no part, the best process is no process. And that is proven to this picture right here on how much parts have been eliminated.
It's occurred between V2 and V3. The level of integration is really unique for rocket engine. That comes from a lot of work among many engineers to consolidate the hardware. The effect of that is that it's actually a higher reliability design. So fewer parts is cheaper, faster to build. So that allows us to make a lighter vehicle, to make a more reliable vehicle, to overhaul, just build a better rocket. Achieving full reusability of an engine like this is really something that people haven't done before. The goal is to get the engine to behave in a similar way to the engines on commercial airplanes. Frequently in interactions with people outside of SpaceX, the perception is that things far beyond what have ever been done before are impossible. Things being impossible is really to be determined by breaking laws of physics. We are not breaking laws of physics, we're just trying to leverage them as effectively as we can.
I dare you to let me build you a completely free e-commerce store
All right, attention all B-19 operators. This is the final go, no-go poll for today's operations. Our main objective today is a 10-engine static fire.
Static fire is the culmination of the engineering process. We're bringing all of the pieces of the puzzle together and we're lighting the engines. And if you make it through that, you have pretty good confidence that you're in a good position to go fly.
Aboard. On LVN1, looks like we kicked out due to 2 combustors from the apex bank being faulted.
Looks like we have to engine time of 2.135 seconds.
We successfully lit all 10 engines. They were ramping up to power. Everything was looking good, stage and engines combined. However, there was a pad side abort called. So what that means is some sort of sensor tripped, and from there we command a fast shutdown.
It was a hard one, and especially since we had to drop all the engines afterwards, and thankfully 10 of them were salvageable, which is good.
We saw some data right after static fire that showed about half the engines had what looked like mechanical damage, basically as a result of the really fast shutdown. So we brought the booster back to Mega Bay. We then decided to remove all 10 engines from the booster so that we could troubleshoot and understand what's going on those 10 while still making progress on B-19 by backfilling engines from B-20.
All right, attention all operators on LVN1. Today's main objective is a 33-engine static fire on B-19. Okay, go no-go poll coming up in 1 minute.
So we're doing our static fire today with all 33 engines.
This is the final go no-go poll for today's operations. Flight software.
Go.
AY.
Go.
Raptor.
Go.
Stage.
Go.
CE.
Go.
GC2.
Go.
GC1.
Go.
FC1.
Go.
Two has 10, 9, 8, 7, 6, 5, 4, 3, 2, mission.
Wow.
We kicked out early. All teams triage alerts, prepare for offload.
Today we aborted our second attempt of the B-19 full count static fire. We actually had another pad abort on the diverter. We made it through engine startup and then ultimately lost some of our sensors on one of the ramp manifolds. It basically said that the manifold pressure was lower than we believe that it probably was, and it kicked us out at T plus 1.88 seconds. It's just tough because there are some things that are hard to test ahead of time. So the diverter, you can test as much as you want, but you can't obviously test for what theoretical vibe and environment you're going to see when the engines are turned on.
Anytime that you walk into an operation where you want to turn on 33 of these enormously powerful engines and get them all to work together and walk away from it in one piece, that is a win.
I think every test is always a success, and we had a bunch of findings on the ground systems, the vehicle, and the engines that I think were really good to flag at this point, but definitely a bittersweet day.
Yeah, we have this saying called "only the paranoid survive." The idea behind it is that there's an enormous...
That is definitely my motto. Every day I wake up and I always tell myself, I'm going to be left behind. I'm fearful of being left behind. I do not want to be part of the permanent underclass, as Alex Finn has said to me while watching his YouTube videos on OpenClaw and Anthropic and Claude Code, right? I do not want to be part of something that I could help myself and or others around me in order to live a better and comfortable life than working the 12 hours a day, 80 plus hours a week. That's just how my mind has been set. Total paranoia.
Amount of information and data that's coming to you, and if you can use that wisely.
See, only the paranoid survive. I agree with that. That's why I only get 4 or 5 hours of sleep a daily, because I'm always paranoid that somebody is ahead of me. And somebody always is ahead of me. But I don't know who that person is that's ahead of me. I just tell myself that this person is ahead and I need to catch up.
You can usually use that to figure out where things are going to go wrong in the future. And almost every time that we fail something or have something go awry, there were clues in previous data and previous operations that if you had known what to look for and had been good enough and paranoid enough to do so, could have found it there.
It's been 10 months since Massey's had the S-36 anomaly.
Ship 36 was a tough one. We had a CPV explode, and it not only took out the rocket, but it took out a lot of the test site infrastructure over at Massey's.
How do we go make sure if we have an anomaly again, the pad can take a beating and still survive?
Losing a rocket is one thing. We've got a production line for rockets and we can go make more. Losing the physical infrastructure of the launch pad or the test site is very difficult because you need to go repair that over a period of many months before you can get back into testing. Now we have Massey's back online here. We've really built this rocket from scratch, but we've also built the pad from scratch, so it's all kinds of new systems. This will be the first time that we bring together the pad and vehicle pieces to make sure that they all work.
The static fire vehicle is in pre-pad clear, about to get to our static fire pad cleared op state.
We run 60 seconds on ship because you get to see how the vehicle thermals all shake out and just general vehicle performance.
That if you can make it through that you're in a reasonable position to go fly.
Start up. Throttle up. Plus 10.
The journey of SpaceX is a journey to give humans access to the solar system and beyond, which is really the goal for Starship.
Plus 20.
The impact that this rocket is going to have on the world, I don't think most people can really comprehend the change it's going to have.
Plus 30.
This is such a wild ride. The highs are high and the lows are low as we really work to get to ultimately launching people, which is going to be amazing.
Plus 40.
It is not impossible just because it's far beyond what has been done before. We've proved that time and time again.